I feel I should be wearing a black armband for this talk, because for the last year we've been talking about a friend who unfortunately recently met with a sticky end and whose ashes have been distributed around the solar system. This is Comet Ison. Comet Ison. This is a picture actually taken on the morning of 16th of November. It was my best ever view of Ison. This was just after it had had its first outburst. If you remember at the last Sky Notes, when Callum gave Sky Notes, I was actually quite positive about what was going to happen with this comet. Shows how wrong you can be. Because basically the comet at that point had had an outburst. It had brightened up really spectacularly. It had a really nice tail. It looked like things were going really well. Just to remind you, hopefully people will learn lessons from this. They won't, I know, the media won't, but this is what we're talking about, the comet that was going to be brighter than the moon, 15 times brighter than the moon. Well, it was pretty nice. Those of you who saw the sky at night that Alan was on, they were on La Palma. They got some fantastic views as it came down towards perihelion. This is one of the best pictures. This is Pete Lawrence's picture of Ison, and that is a blooming good comet. A really nice comet. So this was in the phase when the comet was basically going through a number of outbursts, brightenings. Thing is, it was a very small object. I was amused last week when ESA had a press conference on the Rosetta probe that's going to 67P, when they gave the diameter of the nucleus of the comet to 3 significant figures. The diameter of the nucleus of Ison probably was, kilometre or so, maybe, possibly, something like that. Maybe a bit smaller. That's the upper limit. So, a small object. And there's a limit that John Bortle came up with a long time ago, which was basically for these sun-skirting comets, where they're subject to huge heating and tidal forces. There's a limit in size whereby comets below a certain limit will break up, and Ison was near that limit. But what we saw prior to perihelion was really good. It got more and more difficult to see, of course, because it got closer and closer to the sun, and so from the ground it became extremely difficult to see. This was taken by Pete Lawrence. When was it you were there? This is on the 22nd of November. This is one of the last pictures known that isn't taken by a solar observing spacecraft. This was from the lucky crew on board the International Space Station, who actually managed to get a view of it on the 23rd. And interesting enough, if you actually download the original picture from the NASA website, you've got all the EXIF data in it, which says it's a 1/10 of a second exposure at ISO 12800. It's obviously handheld with a pretty fast lens looking out the window of the space station. So it's good to see the ISS actually doing something useful, I have to say. Sorry, Alan, about this as well. Anyone who saw the horizon, the sky at night was good. Anyone who saw the horizon on the comet of the century may have been a bit disappointed by what subsequently happened. You'll note, by the way, that it's actually being repeated on the 21st of December. So it'll be interesting to see whether they've done any edits to it. It'll be worth a watch. Anyhow, this is a really nice movie by Rob Matson. This is from the Stereo data. So Stereo was one of the spacecraft that was able to follow the comet as it came in. This little one here is 2P Anchor, and this is Ison. So you see it brightens up really nicely as it comes in. And essentially what's happening is that the comet is having all of these outbursts because of the heating and effects. So it's basically falling to pieces, but at the time it looked really nice. It looked like maybe, this thing really was going to be good. This is from SOHO. So SOHO, this is the C3 coronagraph on SOHO, showing basically what happened to the comet. So coming in, this is Scorpius, comet coming in, overloading here, getting brighter and brighter, and at this time everyone was saying, yay, yay, this comet's going to be great. Then all of a sudden, just watch what happens. It switches off. And about a day before perihelion, production of everything stopped. And essentially what came out of the other side of the occulting disk was a big cloud of dust. And initially we thought, well, at least there's still something there. It's a fairly bright cloud of dust, or maybe it's a bit of a fainter cloud of dust. Oh, it really does look a very faint cloud of dust indeed. Well, okay. It is a very, very faint cloud of dust. But that's what happens when you're a small comet that goes very, very close to the Sun. And so we lost it out of the stereo field of view. It's now actually back in a dark sky, and people have been doing some searches for it, both using CCD images and using wide field visual from very dark sites. The light curve, though, is pretty disappointing. So basically what happens, so all the red dots are magnitude estimates that are reported to the Minor Planet Center. These can generally be discounted because these are magnitudes made by people doing astrometry. They're not really measurements of the comet's magnitude. They're kind of almost nuclear magnitude, which isn't very meaningful. The blue dots are the ones that are interesting, though. They're the visual observations and the visual equivalent observations. Probably the comet reached maybe mag 0 or so at perihelion, possibly a bit brighter if you take into account the SOHO data. So this is all basically data from people who process the SOHO images. But then it falls like a stone. And far from being, a bright comet in the December morning sky, people have done deep imaging. This is some imaging done by Dennis Brzezinski, which went down to about mag 16. I saw yesterday some people have managed to get on the field to about mag 18, looking for any remnant of that nucleus. There's absolutely no sign of it whatsoever. Depending on what size is left, it could be extremely faint. Just an example here, if it was down to 100 meters and it was no longer a comet, it was just an asteroidal type object, it would probably reach about mag 25. That's its brightest, not its faintest, its brightest on January the 1st. It crosses the Earth's orbital plane on January the 14th, so if there's any dust out there, that might be a good time to see the dust because it will all be projected into a plane. But the only observation that I know of that is even remotely likely to be true is from a guy called Juan Gonzalez, who observes from a very, very good mountaintop site. He has seen very, very faint cometary remnants in the past, and he says that he did see the dust cloud on December the 7th. Nobody else has seen this, and he hasn't seen it since. So I'm afraid, I think we have to say that Comet Ison was interesting while it lasted, but it is like the parrot in Monty Python. Basically, it is no more. It ceased to be. Yeah, we can go on. We can go on forever with this, but it is. Indeed, we've done that one. It was only on its perch because it was nailed there as it was going in. But anyway, sadly, it's gone. It's a shame because I was looking forward to seeing a fantastic comet in the morning sky. I really do hope that people learn their lessons from this one, but I know they won't. But we all will, and we'll know in future that, comets are dodgy things to predict, particularly comets like this, which are small, that are discovered a long way out. I mean, part of the problem is things like Alan's doing, discovering comets so far out in the solar system now that people try and predict how bright they're going to be when they're 9 AU out. Anyhow, so that's comets. There's a bit more about comets at the end, but I thought I'd do the obituary first. Starting in the middle of the solar system then, the Sun's been actually reasonably active recently, and there have been some rather nice images. This is a spectacular Dave Tyler image. I was saying to Dennis earlier about kind of the quality of solar imaging these days, and I think Dave Tyler in the UK is certainly the key solar imager that we've got. I mean, just look at the resolution there on that sunspot, absolutely extraordinary. And this is one of Tom Wakefield's images, a really nice composite showing all kinds of photospheric features and spicules and prominences and things outside. So really, really nice kind of things. And even with the sun potentially switching off or kind of solar maximum becoming less and less over the years and us going towards solar minimum, if you can observe the sun in monochromatic wavelengths, there's always something interesting to see. Starting off at twilight then, this is the western view in twilight at the moment, and many of you may, if you've been looking in the right direction, have seen the planet Venus. It's extremely bright. It's at a very large southern declination, so it's not very high above the horizon, but it's quite an easy thing to see, basically in evening twilight now, if you've got a good clear southwestern horizon. I haven't seen any images from the UK. I did actually have a quick look at it the other night in a telescope, and basically you could see that it was a crescent, but that was it, really. This is an image, one of the latest images I've got, actually from Australia, where it was much higher, because it's a long way far south at the moment. This is an Anthony Wesley image showing some interesting detail on the cloud tops. And this is what it looks like at the moment. I have to say this is a simulation. It is not what it looked like in my telescope. Basically, if you screwed up your eyes and boiled a kettle in front of it, is more like what it would look if you look in a telescope at the moment. Another interesting object that's definitely worth keeping an eye on, visible in the evening sky in Delphinus, is the Nova that was discovered earlier in the year, in August. It's now faded down to, basically it's at a plateau. It's stuck at about 11th magnitude at the moment, but it's an interesting object to observe. It's well within the range of many telescopes and certainly many imagers, and it's the kind of thing that all of a sudden it could sort of dive off that plateau and start falling again. So just because it's faded to 11th magnitude doesn't mean that people should give up on observing it. And of course at 11th magnitude it's blinding pan-stars, so there won't be any magnitude estimates of a thing that bright. Yeah, indeed, needs sunglasses. So just a couple of images. This is an image I took in August. This is the Nova there. And this is an image of the same field I took a few days ago. So quite clearly there that the Nova's sort of faded down quite nicely. Definitely worth keeping an eye on though. As most novae, it's in a very busy field. It's in the Milky Way. This is a spectrum that Mike Harlow took of the Nova, and actually this is taken using, unlike many spectra you see these days, using sort of newfangled things like diffraction gratings and whatever. This is actually taken using an objective prism, which is actually an objective prism that Mike has borrowed from the BAA instrument collection. He says one of the problems with using an objective prism is effectively it deflects the angle of the light by a certain amount, which I think is about 7 degrees. So you actually have to point the telescope 7 degrees from the object you're taking a spectrum of, which takes some doing. But anyway, here we go. Here's a nice spectrum of that Nova, and it shows even with equipment like that, amateurs can get good quality spectra of fairly bright objects. Another couple of things that we have in the sky at the moment. Uranus is high up in the south in the early evening, and the moon coming up to full now, so it's going to be drowning out all the interesting stuff for a while. A couple of images of Uranus here. The one on the left is an image by Damien Peach taken on the 6th of October. And the one on the right is a drawing by Paul Abel taken at the same time. So you can compare. Now, I haven't managed to check with them, but they seem to have an orientation problem, because that one has the belts going that way, and that one has the belts going that way. And I checked, both of them had north proceeding marked on the images, so one of them is wrong. And since neither of them are here tonight, I can't ask which of them it is. But if you want to see Uranus, now is a good time to see it. And it's scary that an object that's only 3.6 arc seconds across can be imaged at that level of resolution these days. The moon, of course, as I say, it's coming up to full in a few days' time. Lunar observing is the thing to do rather than much deep sky at the moment. Early in January, though, it'll be new, which is good, because we've got the quadrantid meteors early in January. And this is a Damien picture. I've been dabbling around with a bit of lunar webcam imaging recently, but whenever I see this I really think I must well give up. Damien is just the absolute master of this. He gets absolutely fantastic images. So Dennis, yeah, you've got some competition there. few other things then. Around about midnight in Gemini, of course we've got Jupiter, which is coming up to opposition now on the 5th of January. Definitely worth a look. We have the Geminids, which are actually going on at the moment. And we have a recent outburst, and I've put this in simply because the variable star people would moan if I didn't, of an object called CI Gem. And you can take a pick about which you find more interesting out of these three in a minute. So this is Damien's fantastic picture of Jupiter, taken on the 1st. And then I have an Ian Sharp picture actually taken only a few days ago with the red spot really nicely shown. There's actually been some quite good seeing recently, and of course Jupiter is very, very high up. It's at 23 degrees declination at the moment. So this year coming, the first few months of next year are really the time to look at Jupiter. It's high up in the sky. It'll be high up in convenient evening hours. You really need to use that time, because Jupiter, because it only takes 12 years to go around, will fairly quickly move down. Next year it's down to about 15 degrees, and not long it'll be down south of the equator again. So take the opportunity, if you can, to have a look at Jupiter, either visually or if you're doing any webcam imaging. But visually it's really spectacular if you get a chance to look through a telescope at it at the moment. This is just an example of some images in, I think one of them is methane band, just showing the differences that you get when you image Jupiter through different filters, because you're looking at different levels in the atmosphere. So here's the red spot in methane band, which is bright, and which band, what's this? This is UV, where it's dark. And the boiling image on the right is just to show you what Jupiter looks like if you look through a telescope on sort of usually fairly poor seeing, and process that and you get images like this. So yeah, the Geminids are going on at the moment. The maximum was this morning, 1 a.m. this morning, for anyone who happens to be out there. We actually had some reasonably clear skies where I was. But certainly tonight and the following night it's worth looking as well, despite the fact the moon is irritatingly in the wrong place, as it often is for meteor showers. Although it will be in the right place for the quadrantids. So on the night of January the 3rd next year, go outside and have a look for some quadrantids. The quadrantid is actually a pretty good shower. It's just not usually a very popular one, because it takes place sort of early in the new year when everything's cold and miserable and nobody wants to go outside and actually observe meteors. The Geminids were good. I had my camera running, my video camera running, and I had a quick look this morning at the log that came out of it, and I had 4 bright detections between 1 and 3 a.m. So here's Gemini, Jupiter, here's one Geminid, another Geminid, a third, and a fourth. So there are about 100 detections I've got overall through the night, but these were the four brightest ones. And then this is CI Gem. This is an image by Jeremy Shears of a fairly rare outburst of this object. I had a quick look on the AAVSO to look at the light curve to see if it was worth putting up, and it seems to have gone down fainter than 15, 16, 17 something now. So turning around then from the south to the north, one of the interesting things, which is a variable star but also an interesting deep sky object, is this in Cepheus, the variable star PV Cephei, which is associated with a nebula called Guile-Bedagian's Nebula, or Mr. G's Nebula as people tend to call it for some reason. This is the nebulosity here, and this is an image I took of it early in December. It's actually really quite bright at the moment, and people have actually reported seeing it visually in fairly large telescopes from dark sites. When they couldn't see it before. So this is actually, it's a good opportunity if you happen to have a largest telescope, dark site, and you're interested in these variable nebulae. It's a good opportunity to actually go and have a look at this one, because it's at its brightest, I think, at the moment that it's been for a long time. And I know, David, are you still monitoring this? And yeah, so trying to get a correlation between the variable star, which is at the bottom here, and the brightness of this nebulosity.
Both the star and the nebula are bright.
Yeah. So definitely one to keep an eye on. Then moving around into the morning sky, we have two planets in the morning sky. We've got Mars fairly high up, and Saturn only just becoming visible now in the dawn, as the sky brightens up. These are some fairly old images from Damien of Mars. I haven't actually got anything more recent than that. But Saturn certainly will be worth looking at. I haven't had any images sent to me of Saturn yet, but its rings are now wide open. Definitely going to be a nice sight in the telescope, and of course as the months go by into January and February, it'll be getting higher up in the morning sky. So if you can get up in the morning sky, as you need to for all the good comets that are there at the moment, Saturn is going to be a good target over the next few months. It's always a nice planet. Of course, it's moving south gradually. It's still at a reasonable northern declination at the moment, but the longer you leave it, the further south it's going to get, and then we're going to go through a long period when it's south of the equator and much less accessible from here. So yeah, comets. There are 3 comets that I was hoping to say it's worth getting up for in the morning sky, but of course one of them is dead, which is ISON. But this one, 2013 R1, which is currently in Hercules, which is Comet Lovejoy, has been putting on a fantastic show and is still really good. I would definitely recommend getting up for that one. Basically, you need to be, it's at its best in the morning sky, so you really need to be up about sort of 5 o'clock in the morning to image that one, but it's worth it. There's another comet called Comet Nevsky, 2013 V3, which is actually, Nevsky is one half of the 2 people who discovered Comet ISON, Novichonok and Nevsky. And his comet's actually in outburst at the moment, which is quite good. There's one other which I haven't got marked on here, which we talked about, or Callum talked about last time, which is X1 Linear, which is the comet that Richard mentioned as being in outburst. That's definitely worth keeping an eye on as well. But for pictorial niceness, R1 is the best. Terry Lovejoy's comet is the best. So these are a couple of images near the sort of high-resolution images taken by Martin Mobley near the nucleus, showing the nice structure in the tail. Here's an image I took early December, again showing some structure in the tail, but also some interesting structure, hoods and jets and things near the nucleus. Here's an image by Denis Brzezinski that was taken December 10th, so only a few days ago now, and it's a bit sort of aliased on the screen, but there are actually hoods in here. It's got these things are not, these are quantization because of the projector, but on the original you can actually see some faint hoodie type structures, a bit like we had with Hale-Bopp with this comet. Then a couple of more recent ones. This is an Ian Sharp wide angle picture of it from the 11th. This is this is Mike Harlow again, using his objective prism, taking spectra of comets. So this is a cheap way for you to get your spectra. Don't worry about HST. I mean, comet only needs to be 5th magnitude, admittedly, but yeah. So you've got these swan bands here in the comet image. This is Peter Carson's picture, taken actually from this morning. Now Peter lives in the astronomical nirvana of Essex, where all the best comet images are taken from, but it's a really worthwhile comet, this one, really worth getting up for. And then finally, this is a Denis Brzezinski image again from this morning, taken from up in Talbot Ness in Scotland, where it seems at the moment to be permanently clear, showing that the comet has a really nice tail. So this one is definitely worth getting up for. It's a nice replacement for ISON, really. ISON isn't doing anything. Lovejoy has actually done much better than we thought it would. This is Nevsky. It's more like a kind of normal comet, the kind of thing that us normal comet observers get really excited about. But it's again an interesting comet in outburst. Another picture from Peter. Then just a couple of things finally about stuff that's gone past and stuff that's coming up that's been worth imaging. This is a recent pass of a near-Earth asteroid called 2013 XY8, which briefly, when it appeared on the NEO confirmation page, had a minimum Earth miss distance in 2095 of less than the radius of the Earth. Now that happens quite regularly until you can get more orbital data, but it was an interesting object. It's quite a close flyby. It actually flew by the Moon, came to within 760,000 K of the Earth. And now, with all the astrometry that we have now, we know that it won't come any closer than about 350,000 K in 2095. So if anyone's still around in 2095, it'll be an interesting object to observe, but it's not going to hit us. One of the things was that the Goldstone Solar System radar in the States was wanting to make some observations of this object, and that radar has an extremely narrow beam width. So they made a call for some astrometry, and the nice thing these days is that you know, you can. I got the call from astrometry from Lance Berner at JPL. I didn't even have the telescope out. Within 10 minutes, the telescope was out, slewed onto the object, got some astrometry, sent it back to him within about 30 minutes. Quite a lot of other people got astrometry too, but that meant that Goldstone managed to actually get some radar results. Now, they may not look like much, but they are effectively radar returns from this object. And once they've processed these a bit more, they'll be able to get some information about rotation and shape and other stuff. But it's an example of, again, where kind of amateur, you have a big survey, it's the Catalina Sky Survey, discovered the object, a bit like Pan-STARRS discovering an object. Amateurs did some follow-up very quickly after the discovery, which then enabled another big professional installation at Goldstone to do some radar. So it shows that as amateurs we've still got lots of stuff we can do, even with all this, you know, really high-tech professional stuff around. And even better, amateurs have managed to get light curves on this. This is really nice work by Albino Carnaghi in Italy, showing it's a pretty fast rotator, this, about 218 second rotation period. So Alan showed the picture of this asteroid that effectively spun up and spun so fast it broke itself apart. And you can see that these things can spin really fast. This is spinning around in about 3 and a bit minutes. And what's been really interesting with this is that people have tried to image it. It came closest to the Earth the day after this, and then people were trying to image it, and they weren't actually getting it to about Mag 20 or so because of the effect of phase angle. And by that time, the amplitude of the light curve was something like 2 magnitudes. So that's interesting. And then just finally, a couple of spacecraft. Gaia has been mentioned, and this one at the bottom, which is really close to my heart, Rosetta. So the first one is Gaia. Gaia is going to be launched very soon, on the 19th of December, and it's going to go to the L2 point, so outside the Earth's orbit, and it's going to basically measure the positions very accurately of, I can't remember how many percent of the stars in the galaxy. It's a fairly large percentage of the stars in the galaxy, 1%. Huge number of stars. From our point of view, though, what's interesting is that it should be visible from here on the night that it's launched. And there's a really neat website, this one here, Gaia in the Sky, obspm.fr, that you can put in your location. Because the spacecraft's going to be fairly close, you need ephemerides for your particular location, and it will produce an ephemeris. And for me, in Chelmsford, and for most, well, in fact for all of us in the UK, the best time to see it will be on the 19th at somewhere around 23 UT, so after 11 PM. Nobody knows quite how bright it's going to be, but probably at that time it could be as bright as Mag 12, so it should be easily accessible, and certainly I'll be having a go at imaging, taking some astrometry and generating a movie. So this is where it's going to be, at 23:15, basically just above Bellatrix in Orion. So something worth looking out for, something again though worth watching for the launch, because it's being launched on the 19th, and there's a huge amount riding on that particular launch. It's being launched on a Russian Soyuz from Guyana in South America. Then one thing that I'm really interested in, and which I will be talking about, it's not sort of astronomy, you can't see this, but this is going to lead potentially to some fantastic comet science if it works. And this is the spacecraft Rosetta, which was launched back in 2004. And is going to the comet 67P Churyumov-Gerasimenko, and the plan is that it will be rendezvousing with that comet next year and putting a little lander called Philae down on the surface. Because of the fact that it has to go a long way out into the solar system to rendezvous with the comet when it's fairly quiescent, and because Europe doesn't have what the Americans have, which is basically nuclear power sources for spacecraft, Rosetta gets all its power from these huge solar panels. But it has to go out a long way, and it got to the point where it, and this was planned all the way from the point the mission was launched, it couldn't generate enough power to keep itself going. So basically it was put to sleep. It was put to sleep in June 2011, and it's due to wake up on January the 20th, 2014. So imagine this, it's a huge spacecraft that's been out in the solar system, basically something like 5 AU away from the Sun. For something like 3 years, nobody has heard anything from it. All that's been going on is it's got an onboard computer running software, and one of the things that software has been doing is been counting down a time to the point at which it will wake up. And the planned wake up time is 10 o'clock in the morning, UTC, on the 20th of January, 2014. When the computer wakes the spacecraft up, and there's something like a half-hour uncertainty in that, because basically the accuracy of the clock on board the spacecraft, it then has to do lots of things before the spacecraft can talk back to the ground again. So the spacecraft is going to be in a mode where it's spinning for stabilization. It's got to stop the spinning. It's got to use its star cameras to work out what its attitude is, so that it can basically align itself again so that its antenna is pointing at the Earth. It then, once it's done that, will start downlinking a carrier. And essentially what's happening is that we are hoping that that radio signal will be received on the Earth around about 5:30 in the afternoon of the 20th of January, somewhere between 5:30 and 6:30. There's lots of things that might go wrong. The software has lots of contingencies in it. It's very clever software that if things go wrong it will try and sort itself out, because basically there's nobody going to go up there with a thing to press a reset button. So the software will try and sort itself out. So in fact people won't worry even if they don't receive a signal then, because the software may have gone through some pathways where it's trying to sort out faults. And it's only really the next day that people are going to start to get really worried. But anyway, cross your fingers, because this will be an absolutely fantastic thing. This is a European spacecraft that is going to do something that really has never been attempted before, which is to rendezvous with a comet and put a lander on it and then follow the comet back into the inner solar system as it switches on. And it all depends on the fact that this thing is going to wake up on the 20th of January. So that's pretty spectacular, I think. So, happy Christmas everybody. I hope you do get a chance to get up, have a look at those early morning comets. I think whatever happened about ISON, it was still a really interesting comet to see what happened. I mean, to watch those images on SOHO as it came in and broke up was just absolutely fantastic, but it just told us that comets are unpredictable things. So I've no idea what next year will hold. We'll just have to come back here and find out. But happy Christmas from everyone in the BAA.
Thank you very much, Nick. I have a question. For Comet Lovejoy in the morning, binoculars or the naked eye, or what would you suggest?
Binoculars are good. I mean, it is just about naked eye, but you'd need to be in a really dark site. But binoculars are definitely worth doing, and it's easy. I actually saw it in binoculars because it was just visible in the evening sky. I saw it in binoculars cycling home from work a couple of weeks ago. It was that bright. Yeah.
You were cycling with binoculars?
Well, no, I wasn't using the binoculars whilst I was cycling.
Does anyone have any more questions for me? Okay. Well, thank you very much to all the speakers today. Alan in particular, yes, you are still here, really good. Thank you for a superb Christmas lecture. And Richard, thank you for your talk, which is very interesting, and we look forward to your second one next time. And Nick, fascinating Sky Notes. There's so much going on, isn't there? We live in interesting times, I believe that's what they say. So thank you for coming. Happy Christmas to everybody, and we'll see you next time. And that is 9 days after Comet Rosetta wakes up, we hope. So Nick will be here. Yes, you'll be back?
I'll be back.
And Nick will tell us what's happened. Thank you very much.
Are you coming for a beer or are you
No,
having
I'm meeting my wife and others, and we're going to be going for quite a week.
Okay.
Thanks for the invite anyway.
Yeah, well,
much appreciated.
Thank you. I mean, it was excellent talk.
Oh, thanks for being.